guys are too.
I understand.
All right, guys. Indigo. I'm sorry. Can you get the lights? Oh, what's up? Yeah, can you? Can you? Oh man, you are great. All right, guys. Solve this with a friendo on the whiteboard. So find a whiteboard, grab a whiteboard, put it on your desk, move it however you want. There's lots of whiteboards all over the place. Work with at least one person. Okay. There's one near Hassan too. Let me. I think they're taking away my whiteboards. Oh, there's one over here. There's one over here.
No, we need like a thing. Okay.
There's a bucket of markers near Luciana. There's a there's just a bucket. I was just saying, there's a bucket near Luciana.
And they said Y plus 1.
Mr. Weed, you have 2 hands.
Huh?
You have 2 hands.
So that's plus 1.
How am I doing that? Just don't look at freaks.
Your magic.
Okay. Best of luck, guys.
Someone else's turn. I think it's supposed to be 2. That probably is.
Okay, you two, why don't you go around and help? So Charlie, Petunia will walk around. If you guys don't know where to start, ask them. They're your peers. Okay, so Charlie and Petunia walk around, I guess. Okay, so Petunia's got the board. So Charlie, Dr. Hibbert, go ahead and walk around. So he'll be your reference. He'll be your reference. Just pick at him. Right?
What's that?
What?
Great.
What?
Oh, that you have to square.
I need an explanation of what your question is.
Okay, how do we start?
Please start. Square root goes away for that one. And you have to do K minus 1.
Square root of this, and I was like,
No.
what? So this is just okay. You guys just like step equal and
No.
oh wait, no.
Yeah.
That's how it's okay. So you guys did.
Yeah, I'm coming over.
Step.
You. This is not correct.
No, if you want squaring okay, sorry.
Okay. San, if you guys need more help, San is now a reference too.
Yeah. Okay.
So we got Hassan, Petunia, and Charlie. They are your peer buddies. Your peer tutors.
Oh yeah.
Unless they start talking down to you.
Oh wait.
No condescension.
No condescension.
I don't think you're supposed to take
Okay, so pay very close attention to partner's work. Make sure you guys are understanding why you're doing these things. Are you going to get the reason?
well, no, then it did.
Yeah. Okay, K squared. I would try putting everything on this side.
Effective.
So that.
Okay.
Yeah.
Oh,
Okay.
Okay.
How you doing?
Sorry,
Oh, yeah.
I seem like people like us.
You're okay with understanding
And then well, it's 3.
You could just said 3 or like 3. Right.
Here, so I would keep the K squared
Thank you.
positive.
Okay.
So don't move the k squared.
Yeah.
So you have 3k is equal to k squared. And move both the numbers with k on one side.
Wouldn't work. Wait. Okay, so then 0 doesn't work. So
Yeah. Oh, is that what you have? You should have 0
We're
is equal to k
supposed to like
squared.
do that. I'm just gonna. Okay, because I never do that. Let me do it.
No, that's whiteboard. It's like it's optional. You don't have to
She
copy
said-
it. Yes, ma'am.
What happens if I had action? Okay, that's easy.
So you decided to do okay, 0. Okay. So now what can you factor out of 3k? K squared.
Yeah. The worst. My brother.
3k times 3 minus k.
Yeah, my brothers when they were younger.
So you're at this step here. Can you see this?
Yes, so the answer is.
Like 8 plus 4, what can you factor out of those two? So why didn't you say that you have 2 in there, right? What you did was you factored out k, but you still kept this as 3k.
Oh wait, no, I was fine. This is like the
Not just like last time, I just have to finish.
Yeah, and you don't. The thing is, you don't need to factor out k out of both sides. So that's one thing that you don't have to do on both sides. Because it's only when you add things, you multiply it, right? You change the value. But when you just factor out k times 3.
It's not that much. Yeah, there's only 8.
So what happened to the k on the outside? You have 3 minus k on the inside.
Check Mr.
And then notes on it. Oh yeah, I know. It's
There you go. Okay. Now, what values of k will make this whole thing equal to 0? That's
yeah, like you know, maybe in Pascal, maybe it's 2.
Okay. Yep. K. Yeah, you're right. K would have to be equal to 3. What else? So on the inside, you want to make that equal to 0, right? So you did. So what you did was 3 minus k is equal to 0. So you figured out what k was equal. Or you just found out if k was equal to 3, it would be 3 minus 3 equals 0, right?
Oh, yeah.
Right? So you do it in your head. K is equal to 3. What else is k equal to make this whole thing equal to 0? There is a k on the outside. What would that k have? This element. So what two answers do you think?
But then he was like, one go. But then.
So you say k is equal to 3. Normally, these type of problems, you do the quadratic formula.
Yeah, it was like a weird second one, but the first one was that was a good one.
You kind of.
That's what I always do first. It's so easy. Oh, really? I do this as one. Yeah, I do the. I was called.
Hi, how are you doing today?
What?
You try doing the quadratic formula?
Like how? Oh.
So you have 1.
I never studied only been at 5 like a month. Yeah. I remember. I'm like on a road trip.
Negative.
Yeah. One tree. Yeah, like we constantly. Yeah. There's so much. So I can't believe my like I knew it was bad. Once I read it, I was like,
Okay, so you have k is equal to 3. What else do you have? Oh, you checked it. Are you serious?
I don't if I don't.
When you plug it in normally, you still get, or you can still see the roots there. That's why I changed it on the exam. Last week, if you remember, it just won't happen. I said that the square root of the way they wrote it in the book, they took it as here, I'll show you in just a second. Oh, yeah, I'm not going to
Okay, they're like
because technically I don't think that one.
Chinese, concentration camps. There's
It's
like,
really, really fun.
so there's like this minority
I just haven't
of
really
people
looked
who
at
are
do it
Muslim
for practice,
and
but I
like,
think what they're not taking into account is
really?
your answer is usually plus or minus, so both should be true. You know?
No, it's
So,
like expensive.
I don't know. I think
Do you
I'm gonna have to
choose?
talk about that with you guys today.
Oh, yeah.
Like I
Okay,
checked.
sorry. Yeah, it's your choice. Yeah. Yeah, right.
All right, guys. Go ahead and have a seat.
Yeah.
Let's say k is equal to 0.
I really don't know. I don't really choose that one question. We have to do every single one. He does like extra credit. I thought it was gonna be. He does extra credit. Yeah, you guys have to listen to us. We both do 2 questions. Yeah.
We still got that.
Yeah. Are you not? 2 questions. How many years? Luke was like, oh, you guys are on here. Like, oh, so you're gonna take it next year. And then okay.
Yeah.
It's so scary because he's like, okay, hold on. Honestly, it's not that.
Okay.
It's not that bad.
All right, Indigo. I'm gonna reverse my decision. Just between you and me, I'm gonna go back to checking it. But I'm just know I'm not 100% right now about how this is going to work. So just take into account, Mr. Wade's 50-50 right now, and then by the time I teach the students, I have a definite answer. Which I know it's kind of gonna bother you, because I know you like getting things right. I just don't know what the call should be. All right, guys. So let's go ahead and compare your answer. So your answer should have been k is equal to 3 or k is equal to 0. Okay? No?
Yeah.
Let's see. I think most people are okay with that. You can check around to see if you did not get that. But this is just an exercise right now. So me and Indigo, I think, are whoa. What the heck? Why is this happening? All right, that's not what I want. Okay. I think I might have to reset that. So me and Indigo right now, I've always kind of had a weird shaky feeling about the checking for your solution. Because sometimes I feel like the check's not necessary. Both answers are correct. And sometimes the check does work where if you plug it back in, it just doesn't make sense. So
yeah, only one of them for some of them. Like
yeah,
problems, like most of them, you had to check to see which one was right.
I don't know. Like I felt like last week I caught myself in the middle of doing like if you go back to watch the videos closely, you guys kind of see me backpedal a little bit when I did something and I realized, wait a minute, if I write it this way, both the answers work. So
it depends if you see what the square root, if it's a plus or minus.
That's
what.
Yeah, and I can't explain it really well clearly right now. That scenario that happened, but just for the time being, we'll check her solutions, okay? But just know there are some scenarios that the check, I don't know, like there's something with the square root that you assume that isn't plus or minus. I don't know. I'm kind of getting a little bit crazy right now about what I'm talking about. Okay, so just go ahead and check your solution. Like, let me laser point this. What I mean here. So I think a lot of you guys got here, right? And you guys stopped. Not, I'm not saying everybody, but I'm saying like I definitely would have stopped here and just like, all right, I'm done. Okay. But when it does say check your solution, what that means, actually, what does that mean if I say check your solution, like 0 and 3? Okay, and I'm gonna give it to you because
it means like to go back and see if those answers actually work.
Okay, so yeah, so you have k equals 0 and k equals 3. You want to plug it back into the original equation just to see what actually makes sense. Like if I plugged in 0 in terms for that square root of k is equal to k plus 1 is equal to k minus 1, I plug that back in. I get this weird statement that 1 is equal to -1. Is that true, by the way, that 1 is equal to -1?
No.
Good. or else things would just be weird in life, like, right? Like, my shoe is equal to that table, right? Guys? Like, oh yeah, okay, good. But when you plug in the 3, it does make a sentence that makes sense. 2 is equal to 2 when you do the math. So when I ask you to check your solution, look at your 2 solutions, plug them back in, and see which one gives you a true statement. Okay? Did you guys run into any situations where both of them worked, though? No? Okay, so the book tries to give you solutions that look like both solutions shouldn't work. But Indigo, did you want to add to that?
The only way that I found that both solutions did work is if I plug them back into the
Like this form?
K plus 1. Yeah, that's it. Yeah.
Okay, right. I think what I'm gonna teach you, you're gonna if you go to my calculus class too, we always base that when you do your checks or you do anything to prove anything else, it's always the original form in which it takes. You might manipulate it the way it is a little bit, but there's a different sort of reaction. I don't know, like for lack of a better term, when you plug in things back into the original equation as opposed to like a third step in which you manipulated some values. You're gonna see that in calculus, okay? And we're gonna talk about like when I don't know if you've ever gone the topic of limits, okay? But maybe we'll get into that a little bit, right? Okay. That being said, are you guys ready for proofs? I like that. Yeah. If you don't know what it is, maybe you're better off not knowing what it is. So you're just like, I don't know what it is. So I'm up for anything. Okay. I kind of want you guys to go about it this way. Okay. This is where we start getting to definitions and we start using theories and whatnot.
Do we have to learn the definitions for the test?
I'll provide them. I think over time, I give you guys like cheat sheets for each chapter and section that sort of has all the definitions. And then sometimes you kind of find that you don't need to just memorize them. You just, after using it for a while, you just kind of know them. Yeah.
But like there's like 7 postulates and stuff.
Yeah, we're gonna go over them all, so you just know it. Okay. Does anybody know what math was like back then, as opposed to like? Everybody get all your papers and we're gonna take the quiz. Okay. Before it became that, does anybody know what math was? Like the world of math when it was like first kind of being discovered. Yeah. Can you describe?
So first, everyone is excited because it helped make new technology. And then people were also scared because it opposed, like in history last year, we learned about like people in the scientific revolution, they were figuring out stuff in that which opposed the Bible and stuff. So they got mad, but people wanted to learn and explore. So it's either they were excited to learn or they're afraid to try new things because they might get punished.
You guys can totally judge me for my. You can definitely tell what classes I did well in the high school and what classes I was like, I'm just gonna pass this guy. Okay. I think those were the Dark Ages.
Yes.
Yeah.
No, wait. Okay.
No. All right. Okay. Well, preceding that, meaning that before that time, right? There was an age. I think of it like I'm not gonna call it the Age of Enlightenment because I actually don't know which age is the Age of Enlightenment, but I think before that in Greece. Greek philosophers were the ones.
Yeah, we learned about that.
Yeah, they actually talked about math philosophically, right? You'd be like, hey, what? Can you imagine that? Just like, what is 2 plus 2? Who knows? And they would sit around and discuss, okay, these things, because before we actually knew that 1 is not equal to -1, you had to prove that. You couldn't just write 1 is equal to -1. Duh, okay? There'd be justifications for what you did, and they would write out large papers, okay, and it was actually fascinating. It was like a breaking, like a new breakthrough, and like we might explain things in life with numbers, and that person, as long as we understand numbers on this side of the world, and on the other side of the world, as long as they have an understanding of numbers, we might be able to speak a common language, and we might be able to discover new things. It was like a science. It was like a whole new way of thinking, right? But he wanted to say things. Could add to things, or just you could subtract things, and you have PEMDAS. All these things we take for granted, okay? Which, by the way, a lot of people like in the I think in the 1700s here in America. Like I think the thing is, you guys ever heard about this? Like the average 5th grader, I think now knows more than Benjamin Franklin did in his time in terms of the knowledge. I'm not saying we're smarter than him. Okay, he's a pretty brilliant guy, but the amount of knowledge that he's been taught, okay, is
The
equivalent.
fifth grader remembers all of it.
Yeah, well, yeah. I mean, we'll get into that. Yeah. But where was I going with that, guys? Yeah.
You're talking about how Greece and the big numbers, solid, like checking.
Yeah, well, like, yeah, before we just learn about the information, there are reasons why those things work, okay? So today is your first introduction to proving why these things work. So a lot of mathematicians, their love can either dwindle or it grows after you learn about proving things, okay? Because it's fascinating that you can actually prove just basic theories about plus or minus and be like, oh my gosh, that always works, okay? So, or else, if we can't prove it, then math, for all we know, it's just completely made up out of nothing, okay? It has to be proven over and over again, okay? Everybody got that? Okay, let's go through the first 5 postulates together. Bear with me, I'm going to talk quite a bit. Through any 2 points, there's exactly 1 line. Take your fingers right now and put any 2 points in space right now. What is space? It's all around us, okay? I put it right here, right? Look at these 2 dots. Can I literally draw a straight good line in 3D space? Yes or no?
Yes.
Yes, right? They've proven this, okay, with a little bit more proofs, but wherever I move the dots, okay, there's always a line between them. Not too bad, right? That's your first postulate. This is a postulate. I've created a postulate. I didn't create one. Okay, this has already been made, but you just proven it to yourself. Okay, how about through any 3 non-collinear points, there's exactly 1 plane. What's going on here? Does anybody? What does that mean? Think about that for a second. Through any 3 non-collinear. What does non-collinear mean?
Not connected.
Not connected. What do you mean? Yeah, they're not on a line. So if you can think about it, your head is a dot, and then Mike make 3 dots right now. Okay. Actually, yeah, do that right now. Your head is a dot. Make 2. Okay. Stick out those points. Okay. I'm gonna take a. Don't be scared. Right. I'm gonna pick one of you guys. I'm gonna pick on one of you guys. Okay. Feel like you doing this just at the right time. Okay. Okay. All right. Now I want to see everybody put your head out with those 2 points. Okay. Okay. So Marwa, right now with these 3 points, can we make a plane with her 3 points?
Yeah.
Okay. Good. Okay. Who else? Okay. Luciana, her 3 points. Can you make a plane that hits all those 3 points, including her head?
Make a plane now. Make a plane.
Okay. Ivory, do you see a plane?
Yes.
Okay. Who else wants to try? Who wants to define? Oh, you do. Okay. Yeah, Natalie. Okay. Okay. How about you put your 2 points straight up in the air? Okay. You're gonna try me now. Okay. Can I still make a plane with her head being one of the points? Those 2 points. Looks like it to me. Okay. Oh, you want to try too? Oh, you're gonna give me a challenge? How dare you challenge me? Okay. 3 non-collinear points. I gotta make sure I don't drop this on your head. Okay. Do you defy me? No, you do not. Greece wins. I'm just kidding. Very good. Okay.
Just make it really fun.
That's postulate number 2. Okay. What's the difference between 5-1 and 5-3?
There's 3 points
There's
on the line compared to the.
yeah. The image. Yes. What about the definition though? Through any 2 points, there's exactly 1 line, and the line contains exactly 2 points, or at least 2 points. What's the difference between the 2? What do you think? Why do you think they would write? Yeah. What do you think, Luciana?
Well, 5-1 is speaking more about how 2 points is what makes up a line, but a line can contain more than 2 points, but has to have at least 2 points, is what 5-3 is speaking.
What happens if we only have 1 point?
It wouldn't be a line.
It's
It
gonna
wouldn't be a line. It'd be weird, right? Okay. It'd just be this one singular point in space, or just floating around. Okay. And Adam, whoa, you just went too deep. Okay. But yes, but through a line at least, to what constitutes a line, there has to be 2 points. Okay. Or you can look at the flip side for 5.1. For any 2 points, there's a line. Okay. Does that make sense? Okay. 5.4 is sort of the same thing. It's like if you want to make it clean, you need at least 3 points. Okay. But you can put on more points, right? What if you had 2 points on here and it made a line? would you say that line is on the plane?
Yeah.
Yeah. There you go. That's 5.5. Is that so hard? Right? You guys got 5 postulates down. Okay? You can go to your mom and dad and tell them this. Like, do you know the 5 postulates? You ingrate. I'm just kidding. Okay, you can be pompous now. You can be like, I know more than you. Okay. Okay. I know this is weird. I guess it's just like a little mental break from all the board work that we have. I don't know. Let's see. We got like. Try to give you. Okay, I'm gonna give you at least 4. 4 rulers. I thought I had 4 rulers. Sorry. Any more rulers? Okay. I hate to say this, but one person at your table has 2 rulers for now. Okay. So. Okay. And the rest of you guys can use cross arms, I guess. You know, but it's not quite as good. Okay. If okay, so make 2 lines that intersect either with your rulers or your hands right now. Okay. Okay. I know this is weird, but how many points do those lines intersect at?
1.
What if I keep twisting it around? So move it around however you want. Well, I mean, make it 2D. Okay. Still only 1, right? So some people would be like, well, my ruler can actually get like a 2. It can hit more than 1 point. Okay. Imagine these are thin, straight, real lines. Okay. Like it's only a matter that goes in this thin strand. Okay, so that's what your rulers are. Don't bend it around, okay? And be like, look, I can make a circle around this, okay? Yeah, that's actually really good. How many points is this touching at? These 2 lines here. But at this point, when those lines are kind of overlapping, are these 2 distinct lines anymore that intersect? Okay, so we have to talk about it like as if 2 lines, very at least distinct. They don't overlap. Their intersection should only be at 1 point, no matter how thin you try going. Ooh, what about there? Is that overlapping yet? Oh yeah. Okay, you look closely with a microscope. Okay, which I didn't provide. I'm sorry about that. You just proven postulate 5.6. Okay, so the 2 lines can only intersect at 1 point, or this should only be. Okay. This one's a little bit harder. I guess like. Is there like another board here?
Yeah, over there.
Huh? Okay, there's one here. I know, guys. Some of you guys are just like, I don't think this is necessary, Mr. Weir. But did you enjoy your
I know.
Okay, I know. For those in the back, you guys might want to just stand up here. You might want to stand up to watch this because I'm not that strong. I can't do this. Okay. So there's a plane, right? Okay, there's a plane, and then I'm cutting this line. This is a plane that's cutting across. And it's like, oh no, it's coming right across. Okay, so that's just use your imagination. Okay, there are 2 lines intersect. Those are 2 planes intersecting, right? What shape does this intersection make? Do they intersect at 1 point? You jumped the gun. I was gonna say mini points, Mr. Wee. Oh my gosh, I think it's a line. Oh, you got it, Jimmy. You totally got it. At least how many? Because it's a line, right? Okay, so
Well, it also says right there, so I mean.
You just took the fun out of it.
Yeah, I did.
Okay, so that's postulate 5.7. Okay, those are your 7 postulates that you needed to learn. That's it.
You didn't really have to.
We need to write.
Well, I did. Okay, thank you.
I bet you write it in your notes.
You don't have to. Yeah, you don't have to write this down, but maybe it would help. Does anybody have a book at their table? Not a random. No.
Oh, yes.
A math book. Okay, it would help to do that because I'm going to put up a question now. I'm going to put up some questions here. Okay, they are from your book here. Let me see. You know, I gotta better prepare. Let me get my post-it notes. I want you guys to answer these questions too.
On the board? That's just turning.
Give me a second, guys.
Yeah. You know what? You're not the boss man. I'm scared. I am a young adult. I have every right to do whatever.
Yeah.
I didn't dang it. Not to be bad. Not even I can say. Right. No. I want to
Okay, freeze frame. All right. There are 4 questions I'm going to ask you to answer. Line M contains points F and G.
My nose.
Point E is also on this line. Explain how the picture illustrates that each statement is true, and state the postulate. All I really want you to tell me is the postulate that explains both this statement, this statement, this statement, and this statement. That proves that it can be a true statement. That line M contains. So where's line M in this picture?
Top, all the top left.
Okay, top left. This line M contains F and G. Then point E can also be on the line. Which of those postulates that we went over best describes? So that's why I say, anyone has a book right now? Okay. Yes. Okay. Yes. Okay. So what is postulate 5.3? Maro, did you already remember? Okay, go ahead, Maro. What's postulate 5.3?
That there can be at least 2 points, so there can be more than 2 points.
And it mentions that postulate mentions Indigo. Can you read the postulate out loud?
A line contains at least 2 points.
So the big guy that we see, or the big person that we see that is of interest, is the line first, right? It says the line contains at least 2 points, not that points have a line. Okay. So in here in this statement, it says the line M contains points F and G. The point E can also be in the line. So it seems like the line first, and then you talk about the 2 points. That sounds like more about 5.3 than 5.1. Okay. I want you to. I know there's not any hardcore math, but I want you to write B, then 1A, 1B, and then write down the postulate that best describes those 3 statements.
Is it really called like 5 point whatever? Like the postulate?
It's not really like a postulate 5.3. What? Okay. There are. Yeah, actually, I don't think there are any logical names to these. Yeah, but we just refer to them in this context of our classroom as 5.1, 5.2, 5.3. I'm not really sure if there's actual technical names for that. Okay. But we're gonna name them 5.1, 2, 3, 4, or 5, or 6, or 7. Okay. Go find a partner. Discuss which ones are which. Okay. Find a partner with a book. A person with a book, in case you don't have a book.
How many people have books?
Not it.
Got it.
If I give you my book gives you the answers too.
That's good. I'm good with that. Yep.
There are erasers there you can borrow here.
No, our books will give us the answers too.
That's
No,
yes,
his book is
it might.
No,
but no. You're right. It would give you my book would give you the answers to the guided practices, but in your book it would give you
Right, but it would have the guided practice. Oh, you want to what?
all of them. All of them. Do any of you guys want to come up and take a picture of the table?
Yes,
sir,
we guys for the whiteboard, need marker and eraser.
Oh, grab a whiteboard and then the
No, I have a whiteboard.
the erasers are in that bucket over there. Sorry, that bucket always moves around.
I can look straight.
Okay.
The nice thing with having a book is it tells you the answers.
Indigo. I guess you could check your answers, right, Indigo? Yeah, okay.
Sure, check.
Oh.
Don't say it out loud.
Jeez, I didn't think we were gonna let you in there.
No, we're putting a sick distance off. We have to have a, yeah, we have 2.
We have 2 too, so we have like.
I don't know. I don't know.
And I have a pink one. You have a blue one.
And I have a white one.
And I also have a red one. So we can
I
have
have
a
a
white
white
one.
Oh, you
I want a
A.
white one, but only because my battery's running out of fast.
I have a white one because the A button is
Okay, wait, what?
What did you guys end up getting?
Yeah,
5 points. Hey, let me see. You guys got 5.6, 2, and 3. Okay, yes. You think it's 5.7? I don't know. Okay. All right. So you can read B to yourself right now. But if you have lines that intersect at a singular point, what postulate says that you have two lines intersecting at exactly one point? What postulate did you guys get? Yeah? That is absolutely correct. And in your book, it also stipulates that 5.6 is also the right answer. My book, though, goes the extra length to actually give you the guide to practice the answers. You guys don't get that, no? Well, that's why I don't assign them anymore, okay? Because I'm like, they don't get the solution.
Yeah, they don't. Yeah, last time you gave like a lot of them.
Yes, I know. Yeah. You definitely let me know that. It's like, yeah, we didn't have the solution, Mr. Wee. Nope. Okay. So 1A, what postulate did you guys get for 1A? That 3 points determine a plane. Again, Sophia, do you want to give it a go? Let's see. Is it? I don't know. Huh. Let's take a look. Okay, through any three. Yes. Absolutely, Greg. Seems like you learned well from that weird exercise where I put on the board on your head, right? You can tell your parents that. It's like, Mr. Wade hit me with the board today. It was real cool. I got to learn.
It was so fun. I
Yeah.
learned so much.
Yeah. So what's he teaching you? Like, discipline. No, I'm just kidding. Okay. And then planes P and Q intersect at a line. If you guys remember that weird example I had on the floor, I used all my energy for that. Okay, all my strength, everything. Okay, all my strength. That's like one level beyond strength. Okay, strength. Like Earth is one level beyond Earth. What postulate was that? Who said that? Okay. Okay. 5.7, yes. If two planes intersect, then their intersection is a line. Okay? So I'm guiding you through this because I think on your own, you wouldn't know exactly how to answer these questions. So if it asks you for something like this and it asks you to explain, you don't have to explain. All I want you to do is just identify the postulate that best explains.
So you don't have to write the meaning of it?
No. Okay? It's okay.
Oh, that's all you have to do? You don't have to write the table?
No. You're talking about the proof here?
Yeah.
We haven't gone there, young lady. But I'll show you what I want, okay? Because I think the book kind of is flim-flamming, okay? Like, between many techniques. I don't like their techniques. I just want one technique that I think used to be taught and is still taught classically to this day. This is 5-1. This is the final chapter. Hopefully, is it? It's the final chapter, right? It's the final chapter for this month, or the final section for this month that you have to do. Okay. Let's think about this for a second. Now, I love these ones. You just tell me simply, is the scenario that we paint in part A right here, is it going to be always, sometimes, or never true statement? If two coplanar lines intersect, then the point of intersection lies in the same plane as the two lines. Indigo? Can you prove it to me somehow? Can you show me visually? Or can someone else help Indigo show that visually? We got whiteboards, we got rulers. How would you show? We got people. Anyone want to try to volunteer to go for it? Huh? Why don't I disprove it? I don't think I can.
Try.
Go ahead, Luciana. Yeah.
Okay.
Be brave.
Okay, can I have a ruler? Okay, so if my binder was a plane and you have two lines on the plane and they intersect, the point of intersection lies in the same plane.
Can we move that point of intersection? Try lifting the point of intersection away from the book. Like I mean, with like but you have to keep the two lines attached. Are the planes now on the plane? Or I'm sorry, are the lines still on the plane? Yeah?
Yeah, on a different plane.
They're on a completely different plane, so you can't
So is
do
it-
that.
Sometimes.
If two lines intersect and the point of intersection lines on the oh,
But they're so
they're always
they
on.
have to be in the.
They have to be on the same
so
plane.
that's why they're on the
So
same
yeah,
plane.
so even if they aren't a new plane,
It'd
right?
still be on the same plane.
That point of intersection is it still on that same plane if we move that plane? Yes. Okay. So that is
Technically, it's always.
always okay. And postulates 5.5 states that those two lines, what is it? In between them, they have a point of intersection there. Okay, I want you to do. Okay. Do.
Smooth.
All premeditated and planned. Yes. Okay. Wait. Ooh,
No, Mr. Lee.
all part of the plan. Okay. 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 Tell me if those last three statements are always, sometimes, or never true. Okay. You don't have to write this on the board, but discuss now. Okay. I'm gonna take extra credit for this one. We got 3 different tables. Okay. Okay. So this table, you answer B. This table, you answer 2A, and this table, you answer 2.
Oh.
And I'm gonna write down your name.
I know.
Sorry, I meant this one. But you guys are assigned to do this officially.
No, that's an intersection. That's 2 points is the line. No, this one's sometimes. But it says 2 intersecting lines. Oh, okay, sorry. Yes. Okay. My bad.
And there's more than 3 points because a line has more than
You guys want AC?
Sometimes AC, I'm gonna become a little iceberg.
Yes.
Because if there's 2 lines, there's already more than 3 points. And point 4 is a point.
Ice cubes. It's your answer really
The
cold.
heater is on. AC. Air conditioning. Okay, are we good? Does every table have an answer? Okay, where do we want to start with? Does anybody want to begin? 2B. That's you guys.
Yeah.
Okay, 3 lines intersect in 2 points. Oh. Okay, let's see. Oh, I actually have the answers right here. Can you prove that to me?
Yeah,
Right
Charlie drew something.
If you have
Charlie drew something.
3 lines,
Uh-huh.
this could be line. Well, yeah, this could be line, this could be a line, and then this could also be a line. Not necessarily.
So what are we looking at right now? Are they intersecting at 2 different points? So 3 lines intersect in 2 points.
Sometimes, because you could also have this.
So 3 lines meaning that they have to.
Here.
Yeah, go ahead. Yeah. So you have case 1. So explain to me case 1 right now and to the rest of the class.
A and B are parallel, so those 3, those 2 points.
So they're intersecting at 2 points, okay? And then case 3, or case 2, I'm sorry.
Triangle. So there's 3 points.
So there's 3 lines and they're intersecting at how many points?
3.
Can you show me a case where all 3 lines intersect at 1 point?
Yeah.
Any dissenting opinions about this?
Yeah.
Kind of like a pizza, basically.
What?
It's a weird looking pizza. If I'm not gonna lie.
Like how you cut it.
Pizza slice.
Wait, no, not the triangle.
I think we're curious to see what you mean by that. Let's see what.
No, like
Wait, do they all have to
There's
like?
a third
Does
case.
each line have to intersect with the other 2?
Let's discuss this. Okay, so what's your answer?
Pizza
Sometimes.
slice.
Okay, pizza slice. That's what you're gonna write as an answer.
No, sometimes.
Sometimes. Okay.
Well, it depends if all 3 lines. each line has to intersect with the other two.
So here's
If
what
they
your
do, then it has to be.
Luciana brought up a really good point. I'm gonna give you guys the answer. Okay, I'm gonna give you guys that. Okay, so I'm gonna write down your number, or I'm gonna write down your names. You're in trouble. I'm just kidding.
Oh my god.
I'm just kidding.
Patterson is big.
Petunia? Petunia, Hassan, Charlie, and Indigo. Your book, however, says this.
Oh my god. What?
Wait.
But wait,
Depending on the perspective of how you ask the question, Luciana, why do you think
Okay.
this would be never the way they think? Yeah.
so if you think of it as 3 lines have to intersect, they don't all have to intersect with each other. It could be sometimes, but if they're talking where each line has to intersect with the other 2, then it would be never, because it would be.
You wanna prove it? Go
Were
ahead.
the people who wrote the. Okay, so if this line had to intersect with.
Do you need an extra hand?
Okay, yes, I need yes. So if this line has to intersect with both of these, this wouldn't work if this has to intersect with this. So it could be like that, so that this line intersects with both, but it wouldn't be 2 points. It would be 3.
Has to be 2 points.
Oh, so that's how you interpret it. Okay, all right, yeah.
So it depends on how you look at it,
Wait,
because
what's the book say?
So the book looks at it like this: if the 3 lines all intersect together, like they all have to intersect, like 3 simultaneous, like they can't like intersect 2 intersect here while 2 intersect here, right?
it could
They
also be
all have
1
to
point.
intersect. How many points are they intersecting at? You see what I'm saying?
It could also be 1.
That's what I'm saying.
It could be
So
1 or 3.
so the way you could interpret that too, that I take it that the book did, is that when they're talking about the intersection, they're only talking about all 3 lines intersecting at the same exact time and at a single point. So
It
they say
depends on how you look at it.
However, I think the most comprehensive answer, I think, would be that. So I would say sometimes too. Okay, so I would say sometimes. That's why I'm giving you guys credit. Okay.
So it could be sometimes or never.
Oh yeah, your book, your solution there might say never, but I will give that a sometimes. So you can argue that.
It depends on how you look at it to give you the answer, because it doesn't specify.
That's correct. That's correct. Okay. Let's give you a break, Luciana. Let's go to 2A. Okay, so you guys are the biggest table. So you guys agree on an answer. Let's go back to it.
We did agree.
All right. What do you guys agree on? That 2 intersecting lines determine a plane.
Always.
Yeah, we said always because a line has to have 2 points, and a plane has to have a line has to have at least 2 points, and a plane has to have at least 3. So if you have 2 lines, you have 4 points. So we said it's always going to
All right, let's see. So this line has to have how many?
At least
be 2.
What postulate says that? That a line has to have at least 2 postulates. Or 2 points.
1.
Okay. Not 5.1.
5.3.
5.3.
5.3. Okay. This line has to have how many points? Okay.
2.
That'd be funny. This line has to have 5.3 dots. I'm not helping you out here. I'm sorry. I'm teaching you the wrong thing. Okay. So how many points total at least do I have to have for 2?
4.
At least 4, right? Could you say no matter how I twist this, okay? No matter how I twist this, it always makes a nice plane, right? So on this plane, okay, I think on this plane, I think the original question was 2 intersecting lines determine a plane. How many lines or how many points do we need on a plane?
3.
Okay, so this has 4, right? So will this make a plane?
Yeah.
For sure, this will make a plane. So this is an always statement, okay? Okay, no pressure. You guys are the last ones, okay?
Wow.
So number 2, 4 points are collinear
Or not.
or non-collinear.
Sometimes.
Sometimes.
Okay?
You want us to demonstrate?
Yeah, please demonstrate. Okay, so watch, guys.
So,
Unless-
if there's 4 points, they can be like this on a plane. If each of my fingertips is a point, and that doesn't necessarily mean that they're collinear.
But it could also.
None of those are on a line. It could be like, oh, over here. But it could also be like this, or like this, or like that, or like that, and then they could be collinear. So not always, but possibly.
Okay. All right. Sometimes is the correct answer. Very good. Round of applause for everybody. Okay. I think so. Pretty much, I got an easy way of doing this. Who is not here today?
Tessa.
Boo, bad.
Kylie. Kylie's not in this class anymore.
Tessa. Okay, so no Tessa, no Kylie.
No, Kylie's in this class. Kylie's
No, I'm sorry.
not-
No. Who else is not here? Dash. Okay, he's not here. I hate doing it this way, but it's the fastest way I can think of. Is that it? No Tessa, no Dash, no Sierra. Just kidding. Okay, I know. Anybody else? Is that it? I believe. Oh yeah, I believe so. Ava's not here. I love your eyes. Mr. Wee. All right, now take out a piece of paper. Everybody take out a piece of paper. What time is it right now?
It's been out.
It's 10:15.
Okay, so we still got. Okay, so this is the last thing I'm going to teach you guys today. You guys gonna learn it. Then you guys, hold on. Then afterwards, I'm gonna have you do one problem on the board. That's it. It's actually not that bad. And then you guys are gonna go home. Okay?
Home.
Next.
At 1:50, we're gonna wait.
150 is your next class?
Yes.
Oh. What class is that? Oh. It's not like she picked the class, you know. That's funny. Okay. Okay, so this whole time we have been doing 5-1. 5.1. I'm sorry. Okay, I'm sorry. I'm so sorry. I'm sorry.
Wait, are you just writing what we've been doing, or?
No. We're gonna write something new. Okay. So the rest of the things, I feel like.
5.1?
Huh?
Is it actually 5.1?
Yes, it is 5.1. I am not guaranteeing, but I'm saying it's strongly 5.1. Okay? There's a strong chance it's 5.1. So this, I'm not gonna rewrite what we've learned so far. I feel like the first half, that's pretty much the first two examples in the book. I think it was better done with explanations and just kind of interacting. Okay. But this next one requires a little bit of paperwork to kind of describe what you're gonna do. So we're gonna do what is looked at as like when you say proof to a high schooler who's already graduated, this is what they're thinking. Okay. And in fact, a lot of them have to state about it. I didn't like that part. Okay. But so far, I feel like for a lot of people that didn't previously like algebra, like this is the geometry part of like math, they start liking the math. It's like, huh, it kind of makes sense. Some people have the maybe opposite effect, and it's perfectly normal. They're like, I like everything up to this, Mr. Wheat, and I hate you. Okay? So that's fine.
We don't hate you.
Yeah, we just hate. Yeah, we don't hate you. We just hate you and me.
Exactly.
We're just you.
You guys aren't a good match. I never liked that.
Okay.
So wait, are you a science and math teacher?
Yeah.
Yes. I teach a subsect. of it. Yes, I am. Okay. So, okay, wait.
A paragraph.
Fayad. Why do you have that reaction? It's okay.
Okay, I understand it, but like the writing part, it's like too excessive. Do you know what I mean?
Yeah.
To Midpoint, they just
So,
add too many words.
so in your book,
Write a paragraph. This is an English class, Mr. Wee.
Yeah.
give me a second, guys. Just give me a second, okay? So, in your book, you have writing this paragraph proof, and then I think that's example 3, and then down here, like in your book, that's like a problem that asks you to use, like to look at example 3 and write that, and then all of a sudden, and then you go to the next chapter, and then you get write a algebraic proof, and it's got this weird table, and then I think there's another one where it's like ask don't worry, I don't expect you to just know this, okay? But then I think there's another one that asks you to make a tree or something. It's like write me a tree proof. Okay.
What are you teaching?
Okay, I'm teaching you how to prove.
I love how math starts out. It's like, 1 plus 1 is 2, right? And then we're going on and
plus
like
2 is
I
three.
is -1.
No,
and
it goes
from
from
tree.
No, it goes from 1 plus
Okay.
1 equals 2.
We're gonna get into
writing
cooking
paragraph
pretty
math
Okay.
class. I mean, what is this?
Write this up.
Okay, so please write this down. This is going to be an example problem. I'm going to show you how I want you to solve for this, okay? So given that M is the midpoint, and I know it's not going to make too much sense right now because you don't have a visual here, but try to envision this. There's a point M, and it is the midpoint of this X, Y with a weird bar on the top, okay? And it will ask you to write a paragraph proof. So a typical question will look like this. Write a paragraph proof, sorry. The way I wrote it looks weird. Proof to show that XM bar is congruent to MY. So there's a few things in here that you might have never seen before that just drop you right into the geometry. So we're going to kind of go through this right now. So given that M is the midpoint of XY, if I write XY with a bar on the top, can you visualize what they're talking about? Okay, I'm gonna give it to someone I have not heard from. Marwa, I actually haven't heard from you. Go ahead.
It's like the line between X and Y.
Yeah, it's a line that goes between a point X and a point Y. So we can draw that visually. X to Y is the line. Okay, and then what about M? Where is M going to be?
In the middle.
And then the one you've learned about postulates, and there's one more thing to learn from this chapter. I think it might blow your mind. You've never seen this before, I don't think. So before we go on, I have two things to go over before I show you how to answer this, okay? It's called the midpoint theorem. I see eyes that have never seen this before. If M is the midpoint of, let's say, a line A to B, what can you say about AM and MB?
They are equal.
Hold on. Okay, Luciana, go ahead.
Well, they're equal because it's the middle and it's hot.
And then how you justify, yeah? Whoa, go back. What did you say? Wait a minute, I don't know what you mean by that. How do you know it's, wait, where does it say congruent? I think it's equal. What do you think? Oh, go ahead, Sophia.
The equal sign has that weird squiggly line on top. It means congruent.
What? Oh, gasp. Okay. So, yes, there is a difference here. It's not just equal, but it's congruent. Let me go further. What's the difference between being equal and congruent?
Question. Good question.
Good question, yes.
5 is equal to 5, but 5 is not congruent. 5 maybe?
Kind of get there. I do want you to compare and contrast two examples where it's congruent and one is equal. Yeah?
When you wanna compare shapes, like a line is a shape, you usually use congruency.
Okay.
And then for like algebraic stuff, you would use equal because they're the same thing. But for congruent, they're basically the same thing, but for shape is a different case.
Okay, we do attribute it to shapes. Yes, shapes demonstrates a good example between
Like you don't say 5 is congruent to 5. You say like triangle A is congruent to triangle B.
Okay, yeah, go ahead.
Maybe it's because AM is a different line from MB, but they're the same length. So AM isn't the same thing as MB because they're different points, but they are the same length, so they're congruent.
So you guys are all alluding to, I think, things that are actually connected to each other. One example in real life I can give is, let's say I'm 300 pounds of bulk, okay? 300 pounds of bulk, right? And then Dr. Hibbert is also 300 pounds of bulk. We have equal amounts of bulk, correct? We are equal in value. However, my shape, is it congruent to Dr. Hibbert's shape?
No.
Go ahead and stand up, Dr. Hibbert. In fact, how would you describe Dr. Charles or Dr. Hibbert differently
Am
from
I a doctor?
Dr. Lee? I don't know. We are equal, though, in our mass, yet we are not congruent. In what ways are we not congruent? Go ahead. Well, be specific, okay? Go ahead, Indigo. What? Hey! You went too far, okay? Cross the line. No, I'm kidding.
You didn't go far. It's just honest.
It's just straight.
We're just naming
It's
things.
just straight math. Okay. All right, go ahead and have a seat. Okay. You went too far. Okay. So you have to know equality has to do more with the value. So I think even Ivory, you're kind of alluding to that. That when we're talking about value, yeah, you could be 5 is equal to 5, right? But the shape you have to take into account. So you don't have to write this down. Another way of kind of looking at it is the surface area of, let's say, a circle might be equal. So the surface area, don't write this, okay? The surface area of this circle might be equal to the surface area of this rectangle. The amount of the surface that is on this circle might be equal to the amount of surface that's on this rectangle. That's an attempt at a rectangle. I am sorry, okay?
You could have literally just used the lines on the paper.
Just bear with me. Okay, the surface area might be equal, but the shape itself isn't exactly alike. So, are they congruent? No.
You don't know.
So, congruency has to do with two things. You do have to be equal in its value, and the shape has to be exactly the same.
And it sucks. Oh, no.
In a what?
No, never mind.
Oh. But the actual numerical value might be equal. So when we talk about equality, we're talking about numerical values. And when we talk about congruency, we're talking about shapes, okay? So that's why when we're talking about geometry, we typically look at the shape. So we're not just looking at how equal they are in length, but we are looking at the fact that they're equal they look exactly the same in the shape. XM is very similar, or actually congruent in its shape to the MY. Did I write that right? Yeah, the MY line, okay? They're both congruent, and you could say they're equal in the length, but what's even higher order is that they're congruent, okay? Okay, so that's our thing. So here's what I'm going to do. Here's how I'm going to write my paragraph proof. Are you ready for this? Okay.
Does it literally have to be 5 sentences?
Nope. Okay, so from now on, we are only going to stick to one method of proving. It's the algebraic proof. It's a table, okay? So on one side of this table are what we're going to call statements that we make, and then here is the proofs. We have to use actual like postulates, theories, definitions that we know of, okay? We're going to kind of be like a lawyer here, right? Here are the things we say in court, and then here are the things that justify why you can say it, okay? We got to be lawyers. Now you are mathematical lawyers.
Yeah, like in lawyers, they say in section
Math lawyer.
something that states
Yes.
Blah, 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 blah.
Whoa, yes, yeah, that even takes it further. If you actually know law, I'd be like, well, you can't do that. You can't like cross the crosswalk when it's a red light because law number 3.3 says you can't do this, right?
Be a section technically.
Or a section, okay? You can definitely tell who did not do well in law school.
What if you jaywalk?
Huh? Okay, you would have to find the legal section in the law book that tells you why you can't do that. That's why, though. This is what we're doing. We're kind of putting the actions and the statements on one side, and then what definition, theory, or postulate justifies why you can say that. So here, the first thing is you always start with just a given statement. The very first thing that is given to you. Okay? So the only information that is given to me is that M is the midpoint of who? M is the midpoint. Is the midpoint of X, Y. That is the only information that we are given in the very beginning, okay, of this court case. Everyone knows it. Everyone saw it. It is given right there in writing. You cannot deny that because it is given to you, okay? You don't quite understand the significance yet until 5.2, 3, 4. It'll be even more obvious. But right now, it's a little bit vague right now. Like, I don't understand what a given is, okay? But literally, that's just written. You write down that. And then what we're trying to prove, we want to prove. So the part to prove is to show. To show means I want you to prove it. We want to prove that XM is congruent to MY. So XM, this line, we're saying that this line, we're now making a statement now. We're going further, okay? We're going to go ahead and be bold and say XM is congruent to MY. But we need something that justifies that. Is there something that we learned today that tells us if we have a midpoint, then we have two congruent parts? Okay, hold on. I haven't heard from Indigo.
Midpoint formula?
Midpoint formula?
Theorem.
Very, all right. But we knew what she was saying. But we got to be a little bit more accurate. Like in law, you can't just be like, the first law in the book says you can't do that. It's like, what law is that, sir? I don't know. Okay. You didn't do that. But you got to be exact, right? So just be exact. That's all. So it is a midpoint thing. Your justification is a midpoint theorem. I'm sorry, I didn't mean to say that that's what you did. You went way more steps than that. You're like, yeah, I think it's a midpoint formula. Oh, it's theorem. Apples and oranges, right? So we just gotta clear that up a little bit. Midpoint theorem. And your proofs should be no longer than maybe 1 or 2 statements or 3. Okay. In the future, though, they are going to go up to 14 statements.
This is why I'm not going to take
Huh?
like 10
Yeah, we had crazy problems last year. Yeah, we're just gonna get crazier this year.
No, like 10.
Yeah, it gets the lines get really intense. I think the most is probably 18, 13, 18, something like that.
Who made this?
Huh? Blame the Greeks, not me. Okay, no, I'm just kidding. Okay, so I'm gonna give you one problem, and then you are going to leave on the board. So just show me that you can do this, okay? It's going to seem very familiar because it's going to be the same type of problem over and over, okay? This is your ticket out the door, okay? Given that C is in between A and B, and AC is concurrent to A or CB, write a proof that shows that C is the midpoint of AB.
Okay, first let's write down here. So wait, can you Mr. Reed, is that a B?
That is. Oh, sorry. Give me a. That's AB. Yeah.
Okay, so let's
That is AB. Sorry, that is AB. The last thing says AB.
and it says C is between.
So what statements were given to you? Write down every state. So that's good. Right there. Sophia's got the first one. C is between A and B. Or you just rewriting down the whole question. Okay, Petunia's got it. C is between A and B.
Also
That's
another
1.
given.
And then she's gonna write.
Do I put 2 given? Yeah.
No, I'm not gonna do that. Everything all in one given. Yes.
Oh, okay. Because we used to do 2.
Yeah. I'm not gonna do that. I say put everything in one given. You can do bullet points, or you can do comma. I'm gonna walk around with the solution. When you guys finish this, show me, and then I will show you the answer. And then it's next to Ava.
What do you want to do? Okay, that's it. Okay, and then do the proof to show that C is the midpoint.
Yeah.
So that.
Oh, yeah, you're right.
Oh, C is the voice.
Yeah.
And then just show me the final statement. You're trying to prove what.
Is it midpoint? Is that it? No.
THEOREM. Whatever. EM.
Oh, I put it.
Oh wait.
Oh, that's right.
This is right? Yeah.
What do we do?
Is that it?
Just put away your chairs. Your guys are all. C is between B, C.
Is it just the midpoint thing?
Ooh, you can shorten it down. Fancy.
Basically just say that.
You got it? Let me know.
We got it, Mr. Reed. Yeah.
Okay, what are we supposed to do?
Yeah, I don't know.
You guys have a class after this?
No, but it's improving that.
I'm gonna keep you here.
Mr.
Hi guys. Wait a minute. Okay, so let's see. C is between E and B. And then comma.
1034.
Wait a minute. Indigo.
Excuse me.
You don't have to write. You don't have to write a statement. Just write the rest on the exam.
You're so welcome.
Okay.
Look how everybody else writes, and then look how I write. I write so big.
You go.
I'm not done with my sonnet.
No, I'm not talking about how you think.
Yeah, guys, pick up your work packets because please
Miss.
put away your seats. Thank you guys.
You helpful student and collect rulers.
Oh, that is
So Sophocles.
okay.
How are you doing that?
We can leave now, right?
Right? Yes.
It's okay.
Now we write justification.
Yeah. Oh wait, no. So we guys okay? Mr. Reed, mine is not there. Mr. Reed, mine is not there.
Oh, it's not? Okay, that means.
One.
I remember you did the audit and gave it to me, so that's why I gave it.
One's on the
So
other
I was like
side.
gonna give you zero yesterday, but I'm like, no, I remember I took the.
AC is
One given.
I gave
This is supposed to be given.
Yeah.
You got the because I remember actually.
Thank you. That's not mine.
And I stuck with the chairs.
For the justification. That's mine.
Goodbye, Fayed.
For some reason it says something. It doesn't say that I. What? Did I
No. I think this is my one. I forgot to.
Oh god. Oh, C is between A and B. It's
I
supposed
got
to be
really
C.
good.
Excuse me, miss.
Oh, I forgot to throw away my pen.
Me too. Chairs.
Yeah, just write down what they.
Is between A and C.
Class is over.